Good morning. So in the last class, I was discussing regarding the design of cantilever retaining wall. Okay. So I will be brushing up that and then we'll continue further. Okay. So what are all the things that I discussed there? So it is nothing but the dimensions of the retaining wall. Before that, let me brief up one more thing. Okay. So if I want to design a particular structure, okay, what is the final thing that we will be left out with? So either it is the number of bars or the spacing of bars. Okay. So if I want to calculate the number of bars or spacing of bars, I want to calculate the area of steel. Okay. How much steel you people will be providing? How much it bends, based on that we will be providing the area of steel. So we need the bending moment. How much it bends? What is the load that is coming on the structure? So that much it bends. Okay. So I want the loading. So what are all the load that are coming on the structure? So it depends on the size of the structure, that is the dimension of the structure. Okay. So that's why in this particular cantilever design, I started with the dimensions of the retaining wall. Okay. So now let me continue that itself. Okay. So in the dimensions of the retaining wall, so what are all the things that I discussed? So how to calculate the base of the, how to calculate the width of the base slab, how to calculate the thickness, then height of the stem, overall height of the retaining wall, then top width of the stem, bottom width of the stem, all those things we have calculated. Even the depth of the foundations also we have calculated. Okay. So next we'll proceed with the second step. So first step, it was the dimensions of the retaining wall. Next, let me go with the second step. So what is that second step? So actually in the general procedure, the second step was the calculation of loading. Yes or no? But here I will be changing the heading a little bit. So the second one, okay, the second one is the stability, or check for stability of the retaining wall. Check for stability of retaining wall. Check for stability of the retaining wall. Okay. So if I want to check for the stability of the retaining wall, there are three checks needs to be done. Okay. The first one is the check for soil earth pressure. The second one is check for overturning moment. The third one is check for sliding. Okay. So these three checks we need to do before proceeding into the design. Okay. So what is that soil earth pressure? Whatever the load that we are exerting on the soil, will the soil be able to take up that particular load? Okay. So that we need to check. Then the check for overturning moment. Okay. Check for soil pressure, just now I told. So next it is the check for overturning moment. So whenever the soil is exerting the horizontal pressure onto the retaining wall. Why we are constructing a retaining wall? To retain the soil. So soil will be exerting the force onto it. So whenever it is exerting, it tries to overturn the retaining wall. Observe here. So let me consider this as the stem. Okay. So whenever the soil is exerting pressure on it, there is a chance that it may overturn. So I need to check whether it is safe. So what is the other thing that can happen? So let me think that this is the retaining wall. Okay. So whenever you are applying the soil pressure in the horizontal direction, when the soil pressure is applied on it, there are two chances. One is the overturning moment. So the next one is there is a chance that it may slide. There is a chance that it may slide. So these are the three checks that we need to do before proceeding into the main design. Okay. The first one is the check for soil earth pressure. The second one is check for overturning moment. The third one is the check for sliding. Okay. So let me take up the first one, that is check for soil earth pressure. Check for soil earth pressure. Okay. So now what we want to know is, if I want to know what is the soil pressure that is applying onto the soil. Okay. So from the retaining wall and the backfill, what is the soil pressure that is applied? What is the pressure that is applied on the soil? I need to know. So that's why first we'll calculate what are all the loads, okay, that we are exerting onto the soil because of this retaining wall. So we'll calculate it. So for that, so I will be using a tabular column. For that, I will be using a tabular column. Okay. So be careful, the tabular column is very important. So I will be doing one thing, let me rub this. So check for the stability of retaining wall. Under that, the first one, check for soil earth pressure. So remember that heading, because I want more space to write the tabular column. So that's why I will be rubbing this. So now let me go with the tabular column. I need some space for the drawing also. So let me leave that space. Just a minute. So these are the 4 columns that is required. So the first one is the components. Okay. So what are all the components? Like, so soil, the retaining wall, load, all those things I will be explaining it there. So the second one is weight. What is the weight of that particular component? So kilonewton. And the next one is distance up to the toe. I will be explaining what it is. Distance up to toe in meters. So next, moment. Next, it is moment. It is in kilonewton meter. Now, to enter the values, that is the weight, the distance up to the toe and the moment, I need the diagram. Okay. So I need the diagram. So first let me write down the diagram, then it will be easy to understand. Then it will be easy to understand. Okay. So we know the top width of the stem, we know the bottom width of the stem, this is the toe portion, I know the value of the toe, so it's 1.2 meter, I know the heel portion width also, so it's 2.05 meter. I know the height of the stem, it is 5.5 meter. I need some space there. Okay. So to write the pressure distribution diagram, so what I will be doing is, let me write it over here itself. Okay. So this will be the small h, 5.5 meter, and this will be the thickness of the retaining wall, that is 0.5 meter. So I know the width of the base slab is 3.6 meter. The width of the base slab is 3.6 meter. Okay. So now what are all the components? So that is coming on the structure. I mean the pressure that we are exerting on the soil. So the first one is the backfill. Will you people accept that? So why we have constructed, I mean why we are designing the retaining wall? To retain the soil. So there will be soil over here. There will be soil over here. Okay. So let me concentrate only on this particular portion. Okay, even though the soil is over here, no problem. So what is the pressure that we are applying due to this retaining wall we are calculating? So we'll concentrate on this particular portion. So please remember this. Okay, this is the backfill. So don't you think that it is in a rectangular manner? Okay, so for rectangular manner, the centroid lies exactly at the center. So backfill, let me name it over here. So it lies exactly at the center. I will be calling it as W1. And I have written it here, distance up to the toe. Why only to the toe? Why not to the heel? The reason is, so the soil is over here. Okay, so the soil will be pushing this particular retaining wall in this direction. Whenever it tries to push, the most critical point is this particular portion. If it wants to overturn, it's about this point. If it has to move, so this is the point. Okay, that's why the toe is the critical point. So that's why, remember, I will calculate each and every value with respect to the toe. So I want this particular distance. I will be calling this distance as x1. Okay, so next, after the backfill, let me concentrate on this stem. Let me concentrate on this stem. Okay, so let me only concentrate on the stem. So what is this shape? So it's an composite diagram, I can say. So what I will be doing is, I will be dividing this. Can I divide it like this? So then what happens? So the first one will become a triangle, the second one will become a rectangle. So that's why, so for this rectangle, okay, the centroid will be at the center. I will be calling it as W2, and the distance till the toe, I will be calling it as x2. For this triangle, okay, from 90-degree side, so it may act somewhere over here, that is W3. So the distance up to the toe, so I will be calling it as x3. Be careful. Okay, next, this is the fourth portion. Okay, so it is the base slab. So where the centroid, as it is a rectangle, I can easily say that the centroid lies exactly at the center. But observe here, this is 1.2, okay, this is 0.35, okay, so it is 1.55 totally. So here it is 3.6 meter, half of it is 1.8 meter. So the centroid comes somewhere over here. As I have not drawn it as per the scale, you people might be feeling that, so the centroid should come over here. Nothing like that. Actually, as per scale, if I draw it, so the centroid will lie exactly at the center. So let me call this particular portion as W4, and that distance, I will be calling it as x4. Okay, so now let me write down each and everything now. So what are all the loads that are exerted on the soil? So on the soil, this, on the bottom soil, the backfill load will be exerted on it. Okay, next, this stem load will be exerted on it. Next, this base slab load will be exerted on it. So that's why one by one we'll calculate what are all the load that is exerted on the soil. Okay, the first one is the backfill. So I need to calculate W1. How to calculate the weight? So it is nothing but, weight is nothing but equal to, so it is density of soil into volume. Yes or no? So weight means density into volume. So what is the density of the soil, or the unit weight of soil that has been given in the question? So it is 16 kilonewton per meter cube. 16 kilonewton per meter cube. So this is the density into volume. Okay, so I want to calculate the volume, length into breadth into depth. So now I am concentrating on the backfill. Okay, here also there will be soil. I am not concentrating on that. So due to this retaining wall, what is the load that is exerted onto the soil beneath? I am calculating it. So I am concentrating only on this particular backfill. So okay. So now length. What is this length? Don't you think that? That is nothing but the heel projection length, that is 2.05 meter. And what is the height? So height of the backfill is nothing but equal to 5.5 meter. So length into breadth into in this direction, how much it goes? Observe here. So the retaining wall goes like this. The retaining wall goes like this. So it goes like this. So continue agate. So it goes like this. Okay, the soil will be we are resisting the soil in this direction. Okay, so I don't know till what distance I need to design the cantilever retaining wall. Okay, so and as we are designing it as a slab, we'll consider it as per meter. Till what distance we don't know. So we'll consider it as 1 meter. Okay, so that's why observe here. So it is breadth is 2.05 meter into depth 5.5 meter into what distance? So it is 1 meter. Okay, so directly let me take up that value. So it is 180.4 kilonewton. Okay, now let me calculate. So what is the distance up to the toe? What is the distance up to the toe? Okay, so now W1, okay, from here till here, what is the distance? So it's very easy to calculate. Observe here. What is this width? This is 2.05. Half of it will give me this value. Yes or no? Using the centroid concept. Remember the centroid concept? So total is 2.05. Half of it will give me this distance. Okay. So I will be knowing this distance. Next, plus 0.35 plus 1.2. So from here to here, the distance will be 2.05. So that value is x1. It's 2.05 by 2 plus 0.35 plus 1.2. So which is nothing but equal to 2.57. So whenever you know the W1 and X1, let me calculate the moment also. So how to calculate the moment? Force into perpendicular distance. So force into perpendicular distance, W1, X1. So I want the moment which is given by W1, X1. Okay. If you multiply this and this, 180.4 into 2.57. So what is the value that we will be getting? 464.5. 464.5 kilonewton meter. So we have calculated for the backfill. So now let me go with the stem portion. So in stem portion we are having two types. One is the rectangular projection and one more is the triangular projection. So be careful. So for rectangular projection, first I will be going, that is W2. Be careful now. So in the starting one, it was a backfill, that is the soil. So that's why I considered the density of the soil. Okay, but now I am concentrating on the concrete structure. So now I need to concentrate on the density of concrete. So what is the density of concrete that we need to take? It is 25 kilonewton per meter cube. So density of concrete is 25 kilonewton per meter cube into. So breadth into depth into length. So breadth is how much? It's 0.15 breadth. Depth is how much? 5.5 meter. So it's 0.15 meter into 5.5 meter into, observe here. So this, it will be going in this pattern throughout. Just imagine the 3D diagram. Observe here. I want everyone to concentrate. I will try to write the 3T diagram of it. Try to understand that. That will help you a lot. So this is the retaining wall. Okay. So now what we did. So length into depth into till what distance it has gone. So for that I will be taking it as per meter. So 1 meter I will be taking. Here the soil will be retained. Okay, this is the cross section I have taken. Whatever the diagram that I have written, it is the cross section. Okay, so now 5.5 into 1 meter, because I want to know what distance it has gone. So it's per meter. So what is the value of W2? So W2 value is 20.63. 20.63 kilonewton. Distance up to the toe. Be careful. So from this point till toe. Okay. So total is 0.15. Half of it will give me this distance. Yes or no? Half of it will give me this distance. Okay. So now out of 0.35. Out of 0.35. 0.15 if I deduct it. What will be this distance? 0.2. So that's why 0.15 divided by 2. 0.15 divided by 2 plus from here to here it is 0.2 plus from here to here it is 1.2. So finally x2 value will be 1.475. It's 1.475 meter. So now we'll directly multiply W2 x2. I will not be writing this value directly. I will be taking up the value. So it is 30.43. 30.43 kilonewton. Similarly, let me go with W3. Let me go with W3. Okay. So W3, it's a triangular portion. W3, it's a triangular portion. Yes or no? So triangular portion. So density, yes, it's 25 because it's a concrete structure. Into volume. So how to calculate the volume for that? So it is half into base into height. Okay, area into 1 meter. We want the volume. Volume is nothing but area into height. So area is half into, what is the base? It's 0.2 base into, what is the height? 5.5 meter into, till what distance I need to consider? Till what distance I need to consider? So it is 1 meter. Okay. So now, what is the value? So it's 13.75. Let me calculate the distance up to the toe. That is x3. How to calculate the value of x3? I think you people know that. So in a triangular structure or triangular diagram, okay, so this particular load towards 90 degree side, this is 90 degree side, yes or no? So towards 90 degree side it is b by 3, okay. I want away from 90 degree side, so it is 2b by 3 plus 1.2. Please remember, towards 90 degree if I want, this distance is b by 3. I want away from 90 degree side, so it is 2b by 3 plus 1.2 meter. So x3 is equal to 2b by 3, 2 into, what is this breadth? It's 0.2. 2b by 3 plus 1.2 meter. So what is that particular value? So it's 1.33. 1.33. Okay. So now you just multiply it. W3 x3, you get some value. So what is that value? So it's 18.33. It's 18.33 kilonewton. Okay, done. So what is the other thing that we are left out with? So it is the base slab. It is the base slab. So let me concentrate on that. Let me concentrate on the base slab. So base slab is also a concrete structure. So I want W4. So density of concrete, it's 25 kilonewton per meter cube into, as it is a rectangular section, it is breadth into depth into height. So what is the breadth? 3.6. What is the depth? 0.5. So till what distance it has gone? Observe here. I think it's better to explain using this. So breadth into depth into till what distance? Per meter I will be taking. So breadth is 3.6 meter into depth is 0.5 meter into 1 meter. So what is the value that we will be getting? It's 45 kilonewton. Okay. Next we'll calculate distance up to the top. So I think this will be very easy. So what is the total width? 3.6, and it's a rectangular structure. So where the centroid lies? Exactly at the center. So don't you think that it is B dash by 2? So it is 3.6 by 2. That is 1.8 meter. Let me calculate W4 X4. So if you multiply 45 into 1.8, the value that you people will be getting is 81. Now I want the resultant of all these things. Now I want the resultant of weight, that is the summation of weight. Just add it. 180.4 plus 20.63 plus 13.75 plus 45. So finally you get 259.79. kilonewton. Similarly, let me add summation of moment, or else I will be calling summation of resultant moment. All these things, just add it. So it is 464.5 plus 30.43, 18.33 plus 81. It is 594. It's 594.29. It's 594.29. Okay. So now still we have not entered into the check for soil earth pressure. Okay. Still we have not entered into the check for soil earth pressure. Okay. Just we have calculated what are all the loads that are exerted onto the soil beneath. Okay. So now I will be entering into the check for soil earth pressure. Okay. So now I will be rubbing this tabular column because I need this diagram. So I will be rubbing this tabular column. Okay. So to continue further, so I think today I will be winding up my class. So in the next class, I will be continuing the continuation part of this. That is the check for soil earth pressure. I think you people have understood this. Okay. So thank you. So I will be continuing it in the next class.